This topic looks at the trigonometry of non-right-angled triangles. To begin with, we review our rules for the trigonometry of right-angled triangles. The sine, cosine and tangent rules allow us to solve for a side or angle in a right-angled triangle. Sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. SOHCAHTOA can help us to remember these ratios. Sine theta opposite on hypotenuse, cos theta adjacent on hypotenuse, and tan theta opposite on adjacent. To calculate the value of x in this triangle, we first identified the trigonometric ratio required to solve this problem. We have the hypotenuse x and know that the side opposite the 54-degree angle is 38 metres. This means we're using the sine ratio. Substituting these values into sine theta equals opposite on hypotenuse gives sine of 54 degrees equals 38 on x. We then solve for x by swapping the positions of x and sine 54, then evaluating 38 divided by sine 54 using the trig functions in our calculators. So here we have that x is equal to 46.97 metres to 2 decimal places. When asked to find an angle, we begin the same way. First, identify the trig ratio required. In this case, we know the value of the sides opposite and adjacent to the unknown angle alpha, so we use the tan ratio. Substituting into tan theta equals opposite on adjacent gives tan alpha equals 17 on 22. To evaluate this expression, take the inverse tan of 17 on 22 by pressing Shift tan followed by the ratio 17 on 22 in a Casio, or second function tan, then 17 on 22 for a sharp. We find that the value of alpha is 37 degrees, 41 minutes and 39.27 seconds. To the nearest minute, this is 37 degrees and 42 minutes. The angle of elevation is the angle looking upwards measured from the horizontal. The angle of depression is the angle looking down measured from the horizontal. These types of problems often involve the tan ratio. In this example, we need the cos ratio since we are given the values of the hypotenuse and asked to find the side adjacent to the known angle. The angle through which the eagle looks down from the horizontal is 19.5 degrees. Using parallel lines, we can see that this is the same as the angle of elevation from the rabbit to the eagle. Substituting our values into cos theta equals adjacent on hypotenuse gives cos 19.5 degrees equals d over 87. Rearranging to solve for d gives d equals 87 cos 19.5. So when we evaluate this, we find that d is equal to 82.01 metres to the nearest 2 decimal places.